And next one, we have to also understand the failure physics. When we talk about failure physics, there could be the different terms that we need to be clearly explained. The first one is the failure modes, and second one is the failure mechanisms here. So failure mode is recognizable electrical symptom by which failure is observed. So for example, a short or open circuit or electrical open device input or increase current. And these are the failure modes here. And each mode could be caused by one or more different failure mechanisms. And next one is failure mechanisms here. So the failure mechanisms are the specific physical, chemical, metallical, environmental phenomenon or process that cause device degradation or malfunction. For example, the open circuit for interconnection could occur because of the collision or because of too much current flow. So therefore, the collision or the high current flow can be the failure mechanism for our open circuit of the interconnection line. Or on the other hand, for example, high electric field, dielectric breakdown is another example of the failure mechanism. Since we have talked about the failure mechanism, include the definition related to the failure modes and failure mechanism. So next, we have to also understand what actually the reliable and the failure states are. So failure is actually the transition from the reliable to fail state. As I said previously, it's a time-dependent phenomenon. So failure virtually always begins through a time-dependent movement of the atoms, ions, or electronic charge from the benign sides in the device or component to the harmful sides here. If these atoms or electrons accumulate in the sufficient numbers at the harmful side, the damage can happen. So therefore, we have to understand what will be the condition for the change here. So here we can refer to the very basic mechanism related to the thermodynamics here. So thermodynamics means a reaction naturally proceeds when energy is reduced. So in the transition from reliable to fail behavior, the energy of reliable state exceeds those of the failed state. So that means that in the case of reliable state, the energy is higher, and in the case of failed state, the energy is lower. And therefore, by consider the thermodynamic, that the reaction prefer to proceed to when the energy is reduced, and therefore the process must proceed at a certain rate because the reliable state has a high energy and it prefers to reduce to the energy that in the end which failed state has a lower energy. And similarly, in the chemical system, two conditions are necessary in order for reaction to readily proceed at a constant temperature and pressure. And the first concept we will talk about here is thermodynamic requires the energy of the system be minimized here. So we can refer this to the concept related to the Gibbs free energy. The Gibbs free energy is a measure of the chemical energy associated with the atom or molecules. And the expression is shown here. The delta G is equal to the GF minus GI. And GF is a free energy of the final state. For example, it's a free energy of the failed state. And GI is a free energy of the initial state. For example, the reliable state. And the delta G prefer to approach to the most negative value as possible as delta G can. because this is the case that the system can reach the state of the thermodynamic equilibrium. So here is one example. We can understand how the system will prefer to move on from the reliable state to the failed state. And in this case, this concept can be also well understood by considering the Gibbs potential. So Gibbs potential is defined in such way that any spontaneous changes in the Gibbs potential, delta G, can occur only if the change leads to a reduction in the Gibbs potential. So in this case, if you consider two metal and in between there's a dielectric, and because of the separation of a dielectric, there is a potential between the cathode and anode. So in this case, the Gibbs potential increase. But if there's a certain degradation in our dielectric, for example, there's a breakdown path in the end that can produce a short connection between the cathode and the short here, then Gibbs potential decrease, and this is a failed state here. So in overall, by consider thermodynamic mechanism, the system prefer to move on from the high potential, high-end, high Gibbs potential system to the low Gibbs potential system, and which the low Gibbs potential system is the one that actually have the degradation occurs. And the second requirement is the kinetics here. So once a reaction is thermodynamically possible, it must proceed at a certain rate, and the rate is proportional to the Maxwell-Boltzmann factor, also known as Boltzmann or Arrhenius factor. And then the equation is expressed as the following. The rate is equal to the constant times the exponential minus delta G over RT. And here delta G is activation free energy. And from this equation, we can understand that the degradation is thermally accelerated. So that means high temperature always lead to the faster degradation.